Hey, everybody. Hey, Monica. You guys hear me okay? Awesome. I will share my screen in 1 second. Good sessions all day today. Awesome. All right, well, let me try sharing my screen and we'll see how this works. All right, that looks good. So fun story today. I was planning to do this from my house, and Cox Cable internet went out today. It's been out all day. So that's always a good little wrinkle, but thankfully came here to the office, and I think that'll be all right. I was like, really? All days?
How's it going?
Hey, Monica. Good.
Of course, it's the Friday the 13th, right?
That's true. That's probably why my internet went out.
My alarm clock did not go off this morning. Luckily, I was still able to get up just because I'm used to getting up at a certain time. I was like, that did not go off, and so it's been a little bit of a hectic morning.
Like a weird feeling, like uh-oh.
Yeah. Are you are you in your office or?
Yep, in our Lunavi office.
Nice. Yeah, it's always good to have speakers come in early, and I'm like, okay, the video's on, they're presenting. This is so just comforting. So I do appreciate that.
Nice, yeah. I know. There's been a couple times where I've been just like last second. I did what was it? The Devops in a day. I don't know if you ever heard of that. It's a virtual conference. They have about 30,000 people.
Oh wow!
Attended, and it goes for 24 hours all the way around the world. And the reason I think YouTube then for that, and I was on there early. We tested it, everything worked, and then right before we were ready to go live, it wasn't working. I was like, oh no. But thankfully, it worked at the very last second.
Yeah, it doesn't matter how many times you test. It's just what, things just happen, and it's.
Yep.
It is. Yep. But I feel like people are more understanding without everything that's happening, and so it's
I totally agree.
Yeah. Any fun plans for Thanksgiving?
No, I'm starting to kind of wonder if we should be doing what we're thinking about doing. So I mean, right now we're just planning on going to family's house, but even that seems kind of like, should we even do that now?
Yeah, it's interesting. It's gonna. I mean, especially with the recent spike. It's just we're supposed to go to Chicago to see our family, and I'm like, maybe plans will be changing. I don't know. We'll see.
Yeah, it's definitely unfortunate.
Yeah, and who would have thought? We were preparing for Infotec back in March, and they're like, "Oh, we might not have it because of COVID." Or like, "Yeah, right. Okay, we're going to cancel our event because of this thing that's happening out in Europe." And so, sure enough, we're like in March, all that stuff happened. I'm like, "Wow, this is really interesting." And so, really, just forced us to move virtually, and now technology is really leading the way and helping us stay connected. So it's at least we got that going, right?
Yeah. I know this has been exciting. I think HTC, I thought went over really well, and this seems to be going over really well too. So definitely, it's awesome how we can adapt and make it virtual and have that really work, and still have a lot of the interaction that I think people always really enjoy by going to these conferences.
Yeah. It's we tested different softwares and explored different options, and we're like, well, how do we still have virtual booths, and how do we still have, it's not just a plain Zoom meeting that just, how do we still have that engagement and connection? And so after reviewing so many different platforms, because everyone's like, oh, ours is the best, and so we finally tested that one, and I thought that this is, we have the reception, we have the main stage, we have the breakout, we have the networking, so it really gives a chance and, to really still stay connected and have that experience as much as, possible for being virtual, so.
Yeah, definitely.
So are you normally going to the office or no?
No, I've been working pretty much at home. I think this is like the second time I've had to come in the office since March. So, it's
this is the second time too. I'm like, HTC was our first time going in the office, and then the second time is Infotec. I'm like, oh, I miss my office. I miss my So, luckily the daycares are still. They're still open, so we'll see how that goes. Because when all that happened, I don't know if you have kids, but I have a 3-year-old and a 1-year-old, and I'm like, oh my gosh, I have a daycare at home, and I have to do stuff. Leadership academies are still going on with the capstone projects, and it was a little chaotic, but you just make it work, right?
Yeah, exactly. Yeah, mine are a little older, so they can kind of fend for themselves, but they're still in school every day, which is pretty cool. So hopefully that stays.
Yeah, it'll be interesting to see what happens, but but just kind of, I guess we're just kind of went through that wave. So whatever happens, we're kind of, if it happens, just everyone's in the same boat, so that's what kind of makes it a little bit more comforting that we're all in this together. So if there are dogs barking or kids screaming or whatever, it's like everyone's a little bit more understandable.
Yeah, totally. I know, and it's like people get embarrassed still. I'm like, don't even worry about it.
Right. Yeah.
So hopefully there's no dog barking or kids here in the office. So might not have at least those interruptions. So.
Yeah.
Jess is here, so who knows?
Where's Jess? Tell her to say hi.
Yeah, he's over in the other office. So.
Oh, she is.
He said he was going to shoot some confetti in here, but.
He should. Yeah.
I told him he had to clean it up, so I don't know if he's going to do it now.
Maybe we can bring him live to this chat too. You can actually bring people in here. So Jess, if you're watching, come on out. Just kidding. The last HDC was so fun seeing you guys, do the finale. I was like, oh, you guys are so fun. So
good times.
Yeah. Well, I'm gonna probably hop off because we started 3:15, correct? Yep. Yeah. So I feel like I should have some music or something playing, but then also it's like you don't want to mess with technology because they're like, this is working, don't touch anything,
That's the thing.
Yeah.
Let's make sure. I guess I can advance the slide. That's cool. Right.
you're in the chat with us, say hi. Tell us where you're watching. Well, probably watching from home, but tell us who you're with. You can do a little networking in the chat. And also, if you have any questions, make sure to type them in the chat box, and we can hopefully answer them later or as we go, just depending on however Mike decides to go. But usually the questions are towards the end, so we can kind of go through the presentation.
Yeah, I'll probably do that again. If I tend to look at something somebody writes, it like throws my train of thought way off, and
it's like those distracting kids, right?
Exactly. It's like all of a sudden and I'll like think about the question and like, oh yeah, I should probably keep going.
Yeah.
So, yeah, I probably will take most of the questions at the end. So.
Okay, sounds good. And all the sessions are being recorded, and then you'll be able to all the attendees are able to view them afterwards, which is also nice about this platform. And like it records everything, and for those who want to share, we were able to share the recordings as well. So.
Yeah, actually, that was one. I actually wanted to come back in afterwards and look at the chat from my session, but it was like closed after I think the
let me see if there's a way to enable event chat. Oh, these are all. Yeah, I don't think it records the chat. I know it's only the video.
Yeah.
But if there's any questions, I can maybe copy and paste them for you if they're.
Cool.
Yeah. All right. Any fun plans this weekend?
Well, so this is our second week. I lead a robotics team of 4th through 6th graders.
Oh, where at?
This is St. Roberts.
Okay.
And so this is our second week of that. So we're going to do that tomorrow. So that'll probably be my highlight of the weekend.
Is that in person or virtual?
We're actually doing it in person. So we've got the socially distanced teams and everybody's wearing masks. So we're trying to do it as much as we can.
How often do you guys meet?
Once a week.
Once a week.
Yeah.
You should invite me. I'd love to come and check it out.
Yeah, for sure. It's cool.
Yeah.
It's unfortunately, like last year, we were able to like do tournaments around Omaha and Council Bluffs, but we're not gonna be able to do any this year.
Yeah.
We're just gonna have some internal tournaments. You
can still have like virtual tournaments, and you can.
They have a thing because it's through Vex IQ. I don't know if you've ever heard of that, but they do have a virtual kind of way to do the tournaments, but we didn't opt into that this year. There's just too much up in the air right now. We're like, we'll just go as long as we can and we'll do some stuff for the kids. I think it'll be fun.
Yeah. Well, send me an invite. I'd love to come check it out. And
yeah, we'll do.
All right. So I'm going to go ahead and hop off.
All right.
Good luck. You'll do great.
All right. Thanks, Monica. All right. Welcome, everybody. So, so it looks like it's time to start. Saving the best for last of the day, right? So we're going to talk about building microservices with Kubernetes and Azure. So let's just get started right here. So just a couple of things about me real quick. I'm a solution consultant and our director of our delivery engineering at Lunavi. Work with all of our technical team to really make sure all projects are being done right. If you just hopped on, I was just talking to Monica about one of the things I'm most excited about is I'm the coordinator for our competitive robotics club for 4th through 6th graders, so that's pretty cool. And then definitely, you had my email address was on there, and there's my Twitter account. Always feel free to reach out. Definitely love talking about all this stuff and so forth there. So we'll just keep moving on. Just a little bit about Lunavi. So we are a sponsor of this event, and we were also with HDC, been a long time sponsor as Deliveron. Definitely stop over at the booth. I'm actually going to go over to the booth right after this. So if we run out of time for questions, feel free to come over there, and happy to talk and stuff with questions there. As you can see, Lunavi here, we are a technology consulting company. We help our clients create and manage the next generation of solutions for their business. We have a solutions focused, and we can really help our customers across the full spectrum, from modern applications to data analytics, DevOps enablement, cloud solutions, and managed and hosting services. So definitely a lot there. If you haven't stopped by the booth to check it out, don't do it during my talk. We can meet you over there after this. So a lot of exciting stuff there. So let's jump into our talk today. So the first thing we're going to talk about is why microservices and AKS? So the first thing though is like, why even microservices in general? Well, the first thing, and probably the number one goal I think a lot of us want to do when we are creating microservices, really get to where we can break down those large monolith deployments and really get into more of an independent deployment model, really small enough, again, to have that kind of independent concern. So, and with that concern, really having it more business or domain driven instead of technology focused. And I think that's a really big difference with just normal APIs from microservices. It's there to do a specific business job, and obviously there's the technology still behind it. So I think that's a real piece there. And then we're talking about like cloud solutions. It's really more suited, I think, for building those, and really from an agility standpoint of being able to make changes. Obviously, if it's smaller and more isolated, we can make changes faster. We can then do things like scale it independently. We don't have to scale the entire thing to handle different peak loads and things like that. And then also from a reliability standpoint, making sure that it's always running. Another thing too, decentralized data management. That's a really big piece here. Is really those services will own their own data most of the time, and having that be there too. It's definitely helpful there too. We talked a little bit about the reliability, but also making things more resilient. We talk about the from a microservices standpoint about having those services so they there'll always be failures, but really the key piece in microservices I think helps out a lot is to avoid outages. And so that's the difference there, is microservices can really help from that standpoint. So the next thing, but be careful with microservices. So I'm sure if you've done any research or started creating microservices yourself, they can definitely be challenging. And one of the things I often say is, if you've started kind of going down the path of microservice or thinking about it, obviously we're trying to take like that one single button push to deploy everything down to multiple button pushes so we can do those things independently. But one thing I often, is kind of my litmus test to know, are we doing it at the right level, is if you are still coordinating those button clicks between the other button clicks of the deployments to production, you probably haven't done the microservices at the right level, because those really should be independent. And if they are kind of dependent on each other and have to to push the buttons in a certain order or wait for one thing to get all the way through before another thing can go through, those are more what's called a distributed monolith. And unfortunately, that is really just making the problem worse. So that's kind of the worst of the both worlds, is you still have your monolith, but now you have to click multiple buttons to actually deploy it. So that can definitely be a challenge there. I talked about the decentralized data management and really separating that database, but that can really be a challenge, especially when you're talking about like taking your relational database and then splitting it all apart. Like, what do you do with those relationships? How do you handle transactions? How do you handle, like, if some of that data is duplicated out there into multiple areas, maybe just as like reference data? All those scenarios kind of become more important there, and so that can be difficult. So definitely plan for that. The other thing is obviously microservices is like an architecture pattern, but I do feel like it's much more than that. For example, imagine buying a brand new like 4K OLED TV, and then all you're doing is watching VHS tapes on it. So, you're just not taking the full benefit of that TV by watching just some standard def VHS tapes. And so same thing with microservices. There's a lot more pieces that come along with that. There's engineering practices, there's the culture changes, people changes, really to be able to take full advantage and be able to push that button and deploy to production independently without a lot of friction there. So just to kind of keep that in mind there too. The other thing too is getting to the right size can be very difficult. I kind of call it the Goldilocks size here, is, you don't want to build it too small or too big, but just getting it to that right size. And so we won't really talk about that here in this, but if you are interested in that process or have had challenges, event storming is a really good process to go through to help right size your services as part of kind of like a domain-driven design exercise to really kind of figure out what the right size of those services are. So that's definitely something to keep in mind there. Oh, and I apologize. I actually can't see the questions right now. I think that would actually that would throw me off. Feel free to put them out there though while you're thinking of them, and we'll come back at the end. I'll leave some time at the end to answer questions on this, but I won't probably be doing it during that unless there's something major going on. Definitely somebody chime in through audio on that. So that was kind of why microservices. So why should we use those microservices with Kubernetes, and in particular AKS? Well, before we jump into that, let's talk a little bit about what Kubernetes and AKS is in general. So the first thing is Kubernetes. If you're not familiar with it, it's really a tool, open source tool for orchestrating your deployments, managing the scaling, and your container applications there. And it really is that full life cycle. So it's not just a tool to help deploy your applications to there, but it's also, while it's running in production and can help make sure that the right number of instances are going, that it's handling from a load standpoint of scaling. So there's a lot of like operations things that it does too, but it really handles all of those. And it's a tool Google made and open sourced, and there used to be quite a few similar tools out there. There was Docker Swarm, Service Fabric, to name a couple. And really Kubernetes has become I would say the default, the standard there. So what kind of makes up Kubernetes is kind of the highest end is the cluster. Cluster is really your deployment of it, and the cluster then is made up of nodes. Think of the nodes as like your virtual machine behind there. So that's really your CPU power, and then everything else is really virtualized within there. And there's these workload resources that get defined to help really manage all of your applications. The first is pods. That's really kind of your unit of work, and that's how you can essentially, that's like basically one deployment of an application there. And it can actually be made up of multiple containers though, which I think is really interesting. And we'll talk a little about that later. Deployments is a desired state configuration of how you want your services deployed, including replica state and that just symbolizes how many instances you want to have out there. Then you define your service, and your service is really how you want that deployment to be exposed or networked to the other services. And so we'll show a little bit about that there. And then namespaces, those are a way to essentially group your different resources in Kubernetes, and you can do that either by environment or by product. A lot of different options there. So that's Kubernetes. So when we're talking about Kubernetes, like what is this? What's AKS in particular compared to Kubernetes? Well, so AKS is basically Microsoft's managed Kubernetes service in Azure. And what they do is they basically handle a lot of the complexities that you would have to do before. So if you were actually building your application or building a Kubernetes cluster before, you'd have to get all the machines, install everything. With this, you basically just configure AKS like you would any other resource in Azure. The nice thing is you don't have to worry about any underlying servers, and then you don't have to pay for any of the management servers. So for this, what I want to show you is there's what's called the control plane, and that's really all the nodes that manages the Kubernetes cluster. That's the part that is Azure managed, and essentially Microsoft doesn't charge you for that, which is pretty cool, because that's usually one or more servers to do that piece of it too. And that's like all your APIs and everything that's kind of managing how many instances you have running, anything that needs to be deployed goes through that managed person there. The other part though is your workload, and that's what gets deployed, and that's again through those nodes that I already mentioned there. So that's kind of the piece there. Again, just a real high overview. Didn't want to go into too much detail here because I want to stay kind of focused in the microservices. All right, so we kind of know why why microservices, why Kubernetes and AKS. Now, why should we use AKS for microservices? There's tons of options, and even especially when we're talking about Azure, lots of good options there. A couple things, and these aren't necessarily all AKS specific, like this one here, is one of the big appeals of using, when we're building applications there, is the fact we're using containers, and with containers, essentially the development that we're doing, and we're using the same image that we're actually going to be running on production. So as a developer, I've said this many times, it worked on my machine. Well, one of the promises of containers is that wouldn't happen because it's the same machine in prod as it is in development. So that's there. The other nice thing is there's a lot of options for running Kubernetes. You can deploy it yourself on-prem through a lot of other tools. But by doing it through AKS and in Azure, there's a lot of Azure benefits that we could take advantage of, or key features there. So like managed identity, which is a really good secure way to do that. The Azure AD users, VM scale sets, a lot of like Azure resources that we can just leverage through AKS. So a lot of good features there that we could do. If you've done any kind of development of a service, debugging locally is not bad, but when you actually have to call now 15 other services as part of a microservice deployment, it can get a little bit complicated. And AKS provides some tools to actually make that process simpler. We'll talk about that coming up there. This one here, and this is probably, we've probably spent a lot of time over in the PaaS side of things. One of the nice things about AKS from when we say PaaS, like the PaaS and serverless resources in Azure, with AKS is that we don't have to manage those individual Azure resources anymore. Because AKS is the Azure resource, now we can just basically deploy our services to that. Whereas with the PaaS resources, we have to then manage independently, and like let's just say you have 15 microservices, 15 times of all this, so 15 ARM templates. And the problem is a lot of the ARM templates we're building are like snowflakes. So those are harder to kind of manage and track. We have to then specify like a min and a max CPU for all those resources, how we want to do scaling, how we want to like limit the access to those. Like we might be locking those services down so only other services can call it, or we might want to make it public. We have to do that like at each of those services. So we do that similarly with AKS, but it's a much simpler because we're kind of working in a box, if you will. That makes sense. So those are definitely some things like that. So with that then, so that's really some reasons that I feel AKS is really a good tool to use there. So let's start now showing, okay, well, what does that look like, right? So we're like, all right, I'm on board. Like, let's use AKS, but what does that microservices architecture look like? Here, now this isn't like, the holy grail of microservices architecture. Just an example of one. Just want to kind of highlight some of how we can do things with AKS for these kind of microservices typical things, if you will, there. So in this case here, we just have a SPA client. We're going to be doing some, like going through a very common pattern called API Gateway, also one called front end for backends, and then also just, have some cross microservice communication, and then, also how we're doing the data management. So we'll show that here. So what is it, API Gateway? If you're not familiar with it, what it does is it really provides a single entry point for your service. And this has been really popular. We do this, I'd say, probably on a lot of our systems. One of the nice things is it allows like things like cores and stuff like that. If you have a different URL for your API, you don't have to do that. You can basically do it one, and then it can essentially translate it. And it helps too, if we're talking about having a lot of microservices in the back end, and if we had a UI in the front end and we wanted those APIs all talking to that API, or that client talking to all those APIs directly, that can get pretty chatty because more than likely your client's going to need more than one. So a gateway can also help make it less chatty for those services for like aggregating those calls. There's a couple common features with those. One is the gateway routing. That's the big one here that I was kind of talking about, where you can just have one URL. So I might have my application /API, actually /API, and then like maybe customer would be the API after that. And then my API gateway can say, oh yeah, I know where that needs to go. That needs to go to the customer API. And so it can route that dynamically. And I can just have one nice neat route in my URL for my URL. You can do aggregation. That's again where we kind of pull some of those APIs together to bring something back for the client to help there. And then the other nice thing too is, again, we're trying to do microservices, so we're trying to keep those as small as we can. So if we can have this API gateway take care of a lot of the cross-cutting concerns, that's less that we have to depend on every single API doing. And things like authorization, access restrictions, SSL termination. Those things we can handle at the API gateway, and then our APIs can just do the the business functionality that it needs to do, and not worry about those other things. And so some examples of what that could actually be. Probably the most popular one for Kubernetes and AKS is using a reverse proxy ingress controller. And Nginx is the most popular one that's out there, and that really can do a lot of things. There's an open source version and there's a paid version that gives you some more options there. But that can really cover quite a bit of the functionality that you would need. Just think of it as that's your front door or front to any of your applications with that. You can also use what's called a service mesh ingress controller. So I've actually not used this for the controller there, but Istio and Linkerd are common service mesh tools that you can use inside there. We'll talk a little bit about service mesh later, but those are two popular ones there. The other one I say we probably use more is a combination of the Azure App Gateway, and that has some web application firewall capabilities. So you can basically still, if you're using that for like your other services, you can still leverage that for AKS there. And then also Azure Api Management. And again, that definitely handles a lot of the cross-cutting concerns from an API perspective. But then also some other things. It doesn't do load balancing, so that's where you need to probably use like Azure Application Gateway with that one there. So that's some examples of the API Gateway. Next is we're talking about some of the backends for front end. So this is another common pattern. I would say typically with this one is you don't always do this with the API Gateway because it is kind of a variance of the API Gateway. And with that one is you have kind of essentially a gateway API for each front end. So in this example where we do have both, some of the more like aggregation and some of those features wouldn't be done in the gateway. The gateway would be more just for the routing, and then the backend for front end. The idea here is we have a microservice for the desktop and then another one for the mobile. So again, depending on each of our different clients that we're having a different backend API for it. What that does is it allows you to not have to do a bunch of like shared things that, like supersets and things like that you'd have to do if you're trying to get a lot of reuse. You just kind of say, okay, we're just going to create two separate ones, and then it just does what those clients need, even if they're doing this, same or similar. Lots happening in the backend microservices anyway. The next one is service-to-service communication. So here, we're going to have a lot of microservices, and they're going to need to talk to each other. There's definitely some considerations that need to be made for this. Is like, do we want to do synchronous communication where they're, kind of directly tied to each other, or do we want to do something more asynchronously with like an event grid or some event-driven, or I'm sorry, like Azure Service Bus to do that there. And then along with this is, resiliency is a really big thing. Most of the Azure services have a lot of resiliency built into them. There's also a lot of libraries you could use, like Poly and .NET for building some of those resiliencies. There's a lot of cloud patterns, like retries is the obvious one, circuit breakers, and those types of things to really make sure your systems are resilient. So a couple examples, and these aren't necessarily specific to AKS, but first one is having sidecars. Sidecars are really nice. I mentioned earlier that you can basically, a pod is that unit of work for Kubernetes, and you can have multiple containers in there, which I think is a really interesting design that they did. And what that allows you to do is actually like share like memory, CPU, and also the networking on there. So you can actually say localhost and have one container call another container, like they're both on the same one. And the pattern that's really established is this sidecar pattern. And with that, then you can do a lot of, you can basically have those two do all your networking, do things like some other cross-cutting things. That's where the service mesh comes in. That's a sidecar container that can really handle a lot of the networking and capabilities there. It can do things like resiliency testing. It can do like mutual TLS, those types of things. One I'll talk a little about is called Dapper in just a minute. Another sidecar thing that's a little more focused from a development standpoint, but that's another really good thing there. The other one is if you want to do more of an asynchronous messaging, this is Azure Service Bus. So if you want to have those different services, essentially do more like a pub and sub subscription and just post the message on a topic, and then you have some subscribers of that topic. That's a really good way to help manage those service-to-service calls. Dapper, if you haven't heard of that, that's actually it's something Microsoft created about a year ago. It's actually in release candidate for like a 1.0 release, so hopefully it'll be going out the door here as a final release. But this is really cool because it essentially works across any different any language you're using for containers, essentially. So whatever language you're using, it provides a lot of the cross-cutting capabilities. So you don't actually have to code them and it extracts them from you. So can handle that service-to-service call. It's really nice. So you don't even have to know what that other URL is, because that's something that could change in every environment. It could even change throughout the life cycle of the application. But you can just say, hey, let Dapper call. I want to call the orders API, and it will just know where to go to do that. State management, which is really nice. They can abstract that. You can even do state management in languages that don't even support that natively, because you can just use a HTTP call to do like a add state or get state, and then you can use whatever you want in the backend. Like you could use Redis, or you could use Cosmos, you could use storage account, whatever that might be, you can essentially use that there. You can do things like pub and sub, other ones like actors. So what's really nice is they kind of brought over, I think probably one of the best things about Service Fabric, but left all the extra stuff, that's, can be complicated with it. So if you're doing anything around virtual actors, that's there. And then distributed tracing is another really big one too that I think is a great feature when you're talking about trying to understand, especially maybe where there's a failure when you have 15 microservices. If you have that distributed tracing, you can really help identify that. So those are all capabilities there. Wish I had more time to spend on this one, but a really good piece with that. The next thing here is data management. So this is kind of that last part of handling the data, your databases. Mention about how this can be difficult. Here, one of the concepts, though, when we're talking about microservices, and this isn't necessarily specific to AKS, but definitely, is stuff we would use in our AKS microservices. But I'd say we've done traditional development, ACID is a really big acronym there of making sure our transactions are, everything is wrapped in transactions, so it is saved properly. Well, with microservices and distributed architecture, that gets to be really hard to do. And there's a term called eventual consistency. So that's very familiar, especially when you're using things like document databases and scaling things, really to the internet. It's like, okay, well, if I post to my Facebook wall, number one, do I need that to be available instantly in, Madagascar? No, I obviously, so if it takes a while, or maybe it doesn't even replicate onto Madagascar, that's not a big deal versus, with ACID, you need to have everything in there exactly in the right order it was done. So that's a really big piece there. There's a lot of different techniques you could do for the data management. I'm not going to talk too much detail about any of these. We already talked about the database per service and how you can have kind of that one database there. Also, you can do a shared database. Keep your shared database and have it go across the microservices. It's kind of an anti-pattern, and you tend to build dependencies and start to lose the benefits of microservices. So that's why you really want to try to stay away from that. You could do the Saga pattern, which is a way to kind of manage distributed transactions with microservices. It's right there. API composition is where it can kind of pull together. Basically, if you've got maybe 3 microservices or calling 3 different queries, you can basically pull those together in the code to kind of bring back one result set. So I was thinking of maybe a link to SQL type thing if you're familiar with .NET and that there. CQRS, that's really where our commands or inserts, updates, and deletes can be different than our queries. So basically it separates the two technologies there. And we've used that in conjunction with event sourcing, where, again, when we're passing in those commands and saving them. Essentially, event storming is where we save every change to the database is an insert, and it gives you kind of that playback of like exactly what changed. And if you want to like see what the current record is, you kind of have to like get the max of everything. So it's a real interesting pattern there, and you can do some tricks and stuff with it too. But those are some different database management techniques there. So all that, we're kind of talking about, how that would look when we're talking about a brand new environment. Obviously, we don't always get that luxury of being able to start fresh from a greenfield project. So a lot of times we have different, we might have different things for brownfield or existing applications there. In that case here, it's kind of a similar diagram here, but this is where we start bringing in what's called the Strangler Pattern. And what that does is that really allows you to start peeling pieces off of your system and start turning those into microservices. So you can see in this case, with the SPA application, we might go through everything through the Strangler that's existing. And then it's up to kind of this front end piece that decides, okay, has this already been rewritten to a new microservice? Well, let's redirect there. And really, from a SPA perspective, it doesn't know anything about, that now this has been rewritten in microservices versus the old one there. And so we can eventually keep rewriting those pieces. So hopefully that legacy system, could be eventually removed at the end of that. So that's really the kind of the piece there. What's different? We talk a lot about how we would do that process, but in general, that's we want to try to pull out those things and really identify what are good candidates for microservices and what are those independent things. Oftentimes, microservices are actually easier to develop when we're doing this pattern versus trying to start from scratch, because we can tend to know what makes sense from a microservices standpoint based on something that's already built, versus if we're just starting greenfield and trying to write microservices at the right level, that can actually be more difficult. So it's kind of interesting that, following a Strangler pattern, you can actually probably create microservices easier than just starting from scratch. All right, so one of the things I mentioned about AKS and being able to do better and easier than, if we was just say we're using Azure Functions or even APIs, or app services to deploy all our APIs to. If we're trying to do like 15 of them, just think of like either a solution with 15 projects or 15 solutions open, if we're doing like a .NET type thing, and how we can start up all of those and debug, and then how do we configure all those to talk to each other locally versus how it's configured in there. It can definitely be, even if we deploy to like a local Kubernetes service, that configuration can be difficult a lot of times. So with that, there's a pretty cool tool. There used to be one called Azure Dev Space. It's actually still there, but it's going to be turned off, so it's deprecated within a couple of years. So starting to look more into the Bridge2 Kubernetes. They really do a very similar process, but one does it more on the server side. That's the Azure Dev Spaces, versus Bridge2 Kubernetes is more on the client side. But it does allow you to use it with more Kubernetes clusters than just AKS. There's a few things you can't do with Bridge2 Kubernetes, which is kind of nice, but that you can do in Dev Spaces. But I understand that makes sense to do this kind of locally there. So it's essentially an extension you install in like Visual Studio if you're using C# there, or I believe there's also an extension to VS Code with it. So kind of imagine here. So we're looking here at our application. This is our microservices. We've got a web that calls an orders back end API, that then one of the APIs it calls is a product API to like maybe update the what's currently in stock. So our testers, that would be the URL that they might hit it from there. But now let's imagine we have some developers that are wanting to start testing some, like just do like local testing of like what they're developing. So Mary, she's doing a change to the order API. You'll see here is the Bridge2 Kubernetes has created a additional subdomain on here. So she has now her own URL to the website. So when she hits that, when she's just does an F5 or does the local debugging, it's going to actually go and call the front end web, but then it's going to know when that web calls needs to call the order API. Don't call the one that's deployed. Call the local one on her machine and step through that if she has breakpoints, and then it will go back out and call the product API. So that's pretty cool how that will work. And then let's just say we have another developer here, Jack, and same type of thing for Jack. He's now working on the product API. So he wants it to go all the way through these two, and then for him, he wants to start debugging his local changes there. So really a nice way to kind of help that. And obviously with 3 different things, it's not too bad. But if you imagine if I drew this out to like 15, how that would get exponentially worse there. The other thing is this tool called Project Tie. This is another tool. This is actually one made by Microsoft here that if you go out to the Microsoft Build Conference in May, they did I think it was a cloud native applications with AKS presentation there. They talked about both Dapper, and then they talked about this Project Tie, and this Project Tie looks pretty cool. It's still pretty early beta, so just kind of keep in mind, but it helps you deploy debug, if you're trying to run a Kubernetes cluster and did all your configuration right. It does a really good job of kind of managing that. So if you're running local, it can do that, and there's some distributed tracing capabilities there too. A really nice tool there, and this is one probably want to kind of watch and see how it develops. It's a little bit early there. All right, so that's local debugging. The other thing too, our big thing about microservices is how we're going to scale to the needs and really being able to do that at micro level. There's quite a bit of options you have with AKS. One of them is just being able to do it manually. So we'll show here in just a minute the deployment. So we're going to kind of wrap up with what that looks like. You can go and say, okay, well, I originally just wanted 1 instance, I want 2. You can just redeploy and say that, and it'll do that. There's also, if you want to do it more of an autoscaler, there's what's called the horizontal pod autoscaler. So that will come through and essentially scale it out until it runs out of resources on the node, and then it'll stop. And then if you want to actually scale out multiple nodes, you could do that through the cluster autoscaler. The downside of that, it does probably take a little bit of time. You're basically bringing up a new VM and getting everything ready. If you do have a lot of, ups and downs in your traffic and need to handle that very quickly, Burst ACI, or Azure Container Instance, is another popular option. You can basically create a virtual kubelet there. And then the other option is all of these that I mentioned before are really dependent on the CPU and processor and utilizing, or basically when they're being utilized. So it's a little bit of a reactive mode, if you will. It's already now being pegged, so now we got to scale up. But what's interesting is you can actually use this one called Kita, and it's more proactive. So if you actually were getting too many messages on your queue for it to process, then it will actually then do some auto scaling there. So it's a little bit more proactive. So that's really nice. 2.0 just came out with that. So again, little ways you can do scaling. The last part I wanted to talk about here, so we got about 10 minutes left, and we can hopefully leave a little bit of time for some questions, is the pipelines and what that looks like. If you know me, probably have to include something about pipelines in this here. But first thing is, starting with our repo that we're developing to, leveraging something like Azure Pipelines. And this doesn't have to be Azure Pipelines or anything like that, but that's the example using for this demo here. We're basically doing our continuous integration on that side of it. It's similar to what we do probably with any application, do our build, package, and push. But in this case, we're actually using what's called the Azure Container Registry. So if you've ever seen Docker Hub or anything like that, this is our own private version of that, where images can be stored there. Once we have that staged out to there, then that's when we can actually include our deployment. The interesting thing here is, this is where we'll deploy to our AKS instance. But you don't see it actually deploy. You see configure, and that's because we don't actually directly push changes into AKS. We essentially tell it to the controller to say, hey, we need this deployed, and it actually schedules it and does it itself. So that's one of the things there. So let's just dig a little bit into these here with the last few minutes of our hour. First thing here, so this is our YAML pipeline. This is the first part of it. This is our build and package part of it. The thing I want to really call out is the Docker tasks that are in here. And this is essentially just deploying 2 different services. But you can see we're calling the Docker task to do the build and deploy. And then it's actually calling out to a Docker file, which a Docker file is really our build script for building that. So it's going to execute that. And the last thing here is going to tell what container registry it's going to go to. Here's our Docker file. So again, this is building our image. It goes through a few steps here. The first thing is we're going to pull down like a base.NET image or .NET Core, and then we're going to apply our layers, essentially build our application. You can see here we have like the .NET Restore, .NET Build, .NET Publish. So all the same things we do, we're just doing those here as part of our image process because we want to essentially bake that into our image, so our image then really becomes idempotent for being deployed there. And then the last thing is we want to then kind of apply and what's our entry point of our container. So real simple here. Again, not trying to show like a real complex one, but just simple ideas so you can kind of understand what's happening in this process. And then the last piece is the deployment. So this is back at our pipeline here, continued on. This is one of our deployments to one of our environments here. We're essentially calling this Kubernetes manifest task, and we're essentially creating our image, or I'm sorry, our secret, so that the Kubernetes and registry can talk to each other. And then from a deploy standpoint, we're telling it to deploy these manifests. And we'll dig into a little more what those look like. But these are like, remember the beginning I mentioned the deployment is our like desired state, and this is how we want that configured there. So this is deploying that. So if we look at our deployment manifest, and that's a pretty simple one, but just wanted to kind of show you what it is. In this case, we're just having, we're telling it one instance of it to be deployed. You tell it what image that we're wanting to use is the one we built, and then which port is that going to be exposed on. So then our service is how we now want, how we want to be able to access this. In this case, this is very simple too. And this is really how we're saying port 80 is how it's going to be accessible. And then it's going to be ported to essentially to the back end through the port 3000. The other thing here is the type. It's cluster IP. That just means it's going to be internal. There's different types if we were wanting to expose that there. So again, just wanted to show what a real example, or well, it is a real example, but it's a simple one of kind of what that pipeline looks like. So, all right. So then it really has conclusion here. So we talked about, why microservices, why we want to use why we want to use AKS for microservices, what we want to do, or what those actually look like, and show some examples there, including, what a sample pipeline looks like. So I'm going to now open it up for some questions. I do have a few links here that I can provide, and I will provide the deck here to you if that's something people want. So I'll put that out there so people can use it there. So questions. There's the, definitely feel free to, or please fill out the survey about the session. If you'd like it, anything you want me to change on it, always want to learn from that. Any questions at all going through that? All right, well, again, if no further questions, there's one here. At what point does an application become a candidate for microservice transformation? So great question. I do like how you even frame that up. Again, I think there's a point where it's easier to almost move to a microservice from something. But I would say if there's a lot of complexity in getting your changes, if you're making small amounts of changes to actually get it to go all the way to production, then that can be a good candidate. If if you have a lot of people in the same application making changes and kind of stepping on each other for deployments, and that's other good candidates to start looking at pulling some pieces out and making it so they can deploy independently. I said this feels a lot like architecture for the app to go through. If we're greenfield, how do we even start? Yeah, so I mean, It is definitely, that's one of the challenges too, is, there's always a little, there can be some learning curve to it. I would say, once you get the AKS out there, it's kind of like any of the other services. If you're doing functions or app services, you can get something deployed and running out there, and then, making it a little more enterprise ready. There's definitely some additional steps. If you're wanting to get more hands-on familiar with it, these are some great some hands-on labs out there to start going there. But I would say if you're starting with kind of greenfield, that's where you'd want to start with that domain-driven design and do that event storming, because that'll define those boundaries and where you want to create the services from, and then you start building out those services from there. So that's really where I'd start, Paul. Great. Anything else? Otherwise, if you have some questions there, exactly what Cook said. I'm going to head over to our Lunavi booth, and happy to chat more. We could even fire up the video and chat in person too. So thanks everybody. Thanks a lot for coming, and enjoy your weekend, and talk to you later.